Hi, welcome to a new section of this video course, Template, Memento, and Interpreter Design Pattern. In this section, we will see the next three behavioral design patterns. The difficulty is being raised as now we will use combinations of structural and creational patterns to better solve the objective of some of the behavioral patterns. We will start with Template Design Pattern, a pattern that looks very similar to Strategy Pattern, but that provides greater flexibility. Memento design pattern is used in 99% of applications we use every day to achieve undo functions and transactional operations. Finally, we will write a reverse Polish notation interpreter to perform simple mathematical operations. Let's start with the template design pattern. In this video, we are going to write an algorithm that is composed of 3 steps, and each of them returns a message. The first and third steps are controlled by the template, and just the second step is deferred to the user. The template pattern is one of those widely used patterns that are incredibly useful, especially when writing libraries and frameworks. The idea is to provide a user some way to execute code within an algorithm. In this section, we will see how to write idiomatic Go template patterns and see some Go source code where it's wisely used. We will write an algorithm of 3 steps, where the second step is delegated to the user, while the first and third aren't. The first and third steps of the algorithm represent the template. While with the strategy pattern, we were encapsulating algorithm implementation in different strategies, with the template pattern, we will try to achieve something similar but with just part of the algorithm. The template design pattern lets the user write a part of an algorithm while the rest is executed by the abstraction. This is common when creating libraries to ease in some complex task, or when reusability of some algorithm is compromised by only a part of it. Imagine, for example, that we have a long transaction of HTTP requests. We have to perform these steps. First, we authenticate user and then authorize him. Next, we retrieve some details from a database and make some modification. Lastly, we send the details back in a new request. It wouldn't make sense to repeat steps 1 to 5 in the user's code every time he needs to modify something on the database. Instead, steps 1, 2, 3, and 5 will be abstracted in the same algorithm that receives an interface with whatever the 5th step needs to finish the transaction. It doesn't need to be an interface either. It could be a callback. The template design pattern is all about reusability and giving responsibilities to the user. So the objectives for this pattern are listed here. Defer a part of the algorithm of the library to the user, and improve reusability by abstracting the parts of the code that are not common between executions. A brief description of what the template pattern has to do is to define a template for an algorithm of 3 steps that defers the implementation of the second step to the user. Here are the requirements and acceptance criteria for our example. So, each step in the algorithm must return a string, and the first step is a method called first, and returns the string hello, while the third step is a method called third, and returns the string template. Then the second step is whatever string the user wants to return, but it's defined by the message retriever interface that has a message string method. Finally, the algorithm is executed sequentially by a method called executeAlgorithm, and returns the strings returned by each step joined in a single string by a space. Now, let's move on to the unit tests for the simple algorithm. Now we will focus on testing the public methods only. This is a very common approach. All in all, if your private methods aren't called from some level of the public ones, they aren't called at all. We need 2 interfaces here, one for the template implementers and one for the abstract step of the algorithm. As you can see, I have created a folder called template, and I have 2 files created here, with the names template.go and template_test.go. So let's open template.go. Here, let's add the package name and type interface. A template implementer will accept a message retriever interface to execute as part of its execution algorithm. We need a type that implements this interface called template. We will call it template IMPL. Let's add the code for the template implementer struct. So, our first test checks the 4th and 5th acceptance criteria. We will create the test struct type that implements the message retriever interface, returning the string world and has embedded the template so that it can call the execute algorithm method. It will act as the template and the abstraction. Let's save this file for now and move on to templatetest.go. Here, we have named the package as template and imported strings and testing. Since this is a test, first define the test struct type. In this case, the part of the algorithm deferred to us is going to return the world text. This is the string we will look for later in the test, doing a check of type. Is the word world present in this string? Take a close look. The test struct embeds a type called template, which represents the template pattern of our algorithm. When we implement the message method, we are implicitly implementing the message retriever interface. So now we can use test struct type as a pointer to a message retriever interface. Next, let's add the code for the function test template algorithm. In the test, we will use the type we have just created. When we call the execute algorithm method, we need to pass the message retriever interface. As the test struct type also implements the message retriever interface, we can pass it as an argument. But this is not mandatory, of course. The result of the execute algorithm method, as defined in the fifth acceptance criterion, must return a string that contains the returned value of the first method, the returned value of test struct, that is the world string, and the return value of the third method separated by a space. Our implementation is on the second place. That's why we check that a space is prefixed and suffixed on the string world. So, if the returned string, when calling the execute algorithm method, doesn't contain the string world, the test fails. This is enough to make the project compile and run the tests that should fail. Let's save this file and open the terminal. Type the command go test-v. As expected, the test fails. Cool. Time to pass the implementation of this pattern. As defined in the acceptance criteria, we have to return the string hello in the first method and the string template in the third method. That's pretty easy to implement. Open the template.go file and let's modify the code here. Let me add proper indentation. Also, make sure to change the type template interface to templater, as we cannot have to type with the same name. Save the file. With this implementation, we should be covering the second and third acceptance criteria and partially covering the first criterion, that is, each step in the algorithm must return a string. To cover the fifth acceptance criterion, we define an execute algorithm method that accepts the message retriever interface as an argument and returns the full algorithm, a single string, done by joining the strings returned by the first, message string, and third methods. The strings.join function has this signature. It takes an array of strings and joins them, placing the second argument between each item in the array. In our case, we create a string array on the fly to pass it as the first argument. Then we pass a white space as the second argument. With this implementation, the tests must be passing already. Let's save the file, navigate to the terminal, and run the test. Go test-v, enter. The test's passed. The test has checked that the string world is present in the returned result, which is the hello world template message. The hello text was the string returned by the first method. The world string was returned by our message retriever implementation, and template was the string returned by the third method. The white spaces are inserted by Go's strings.join function, but any use of the template implementation.execute algorithm type will always return hello something template in its result. This is not the only way to achieve the template design pattern. We can also use an anonymous function to give our implementation the execute algorithm method. Let's write a test in the same method that was used previously. So, open the template test.go file and add the code at the bottom of the file. Our new test is called using anonymous functions. We have also extracted the checking on the test to an external function to reuse it in this test. We have called this function expected or error because it will fail with an error if the expected value isn't received. In our test, we will create a type called anonymous template that replaces the previous template type. The execute algorithm method of this new type accepts the func method string type that we can implement directly in the test to return the string world. Now let's save the file and move to the template.go file. Here we add the anonymous template type structure. The only difference with the template type is that the execute algorithm method accepts a function that returns a string instead of a message retriever interface. Let's run the new test, save the file, and go back to the terminal. Let's run the test command, go test-v. As you can read in the output of the test execution, the error is thrown on the using anonymous function test, which is what we were expecting. Now open the template.go. Let's write the implementation by modifying the return statements in the anonymous template type. The implementation is quite similar to the one in the template type. However, now we have passed a function called f that we will use as the second item in the string array we used on join function. As f is simply a function that returns a string, the only thing we need to do with it is to execute the proper place, which is the second position in the array. Don't forget to save the file for the changes we made. Let's open the terminal and run the tests again. Awesome! Now we know 2 ways to implement the template design pattern. Now, a question which may arise here is that, how do you avoid the modifications on the interface? The problem of the previous approach is that now we have 2 templates to maintain and we could end up duplicating code. What can we do in the situation that we cannot change the interface we are using? Our interface was the message receiver, but we want to use an anonymous function now. Well, do you remember the adapter design pattern? We just have to create an adapter type that, accepting a function string type, returns an implementation of the message receiver interface. We will call this type template adapter. Let's open template.go and add the template adapter. As you can see, the template adapter type has a field called myfunc, which is of the type func string. We have also defined adapter as private because it shouldn't be used without a function defined in the myfunc field. We have created a public function called the message retriever adapter to achieve this. Let's save the file and go back to the template test.go. And here, let's add the test. So this is how our test should more or less look like. Look at the statement where we called the message retriever adapter method. We passed an anonymous function as an argument defined as func string. Then we reused the previously defined template type from our first test to pass the message retriever variable. Finally, we checked again with the expected or error method. Take a look at the message retriever adapter method. It will return a function that has nil value. If strictly following the test-driven development rules, we must do tests first, and they must not pass before implementation is done. That's why we returned nil on the message retriever adapter function. So let's run the tests. First, save the file and move to the terminal. Run the command go test-v. The test fails on line 42 of the code, and it doesn't continue. Again, depending on how you wrote your code, the line representing your error could be somewhere else. We stop test execution because we will need a valid message receiver interface when we call the execute algorithm method. For the implementation of the adapter for our template pattern, we will start with message retriever adapter method. So let's go back to the template.go. Let's modify the message retriever adapter. It's very easy, right? You could be wondering what happens if we pass nil value for the f argument. Well, we will cover this issue by calling the myfunc function. Now let's modify the type template adapter struct. So the adapter type is finished with this implementation. When calling the message function, we check that we actually have something stored in the myfunc function before calling. If nothing was stored, we return an empty string. Now our third implementation of the template type using the adapter pattern is done. Save the file and move to the terminal. Let's run the test command. As you can see, we have passed the test. Wonderful. Now, let's see how to look for the template pattern in Go's source code. The sort package in Go's source code can be considered a template implementation of a sort algorithm. As defined in the package itself, the sort package provides primitives for sorting slices and user-defined collections. Here we can also find a good example of why Go authors aren't worried about implementing generics. Sorting the lists is maybe the best example of generic uses in other languages. The way that Go deals with this is very elegant too. It deals with this issue with an interface. Let me show you this interface. I have already created the file sort_example.go. Let me open this. This is the interface for lists that need to be sorted by using the sort package. In the words of Go's authors, a type, typically, is a collection that satisfies sort. Interface can be sorted by the routines in this package. The methods require that the elements of the collection be enumerated by an integer index. In other words, write a type that implements this interface so that the sort package can be used to sort any slice. The sorting algorithm is the template, and we must define how to retrieve values in our slice. If we peek in the sort package, we can also find an example of how to use the sorting template, but we will create our own example. Here add the lines of code, as I do. First, we have done a very simple type that stores an int list. This could be any kind of list, usually a list of some kind of struct. Then we have implemented the sort.interface by defining the len, swap, and less methods. Finally, let's write the main function. The main function creates an unordered list of numbers of the mylist type. We print the list that we created, unordered, and then we sort it. The sort.sort method actually modifies our variable instead of returning a new list, so beware. Finally, we print again the resulting list. Now we are ready to see the console output of this main method. Save the file and open the terminal. Run the command go run sort example.go. The sort.sort function has sorted our list in a transparent way. It has a lot of code written and delegates len, swap, and less methods to an interface, like we did in our template, delegating to the message retriever interface. Superb! Now let me summarize the template design pattern. So we wanted to put a lot of focus on this pattern because it is very important when developing libraries and frameworks and allows a lot of flexibility and control to users of our library. We have also seen again that it's very common to mix patterns to provide flexibility to the users, not only in a behavioral way, but also structural. This will come in very handy when working with concurrent apps, where we need to restrict access to parts of our code to avoid races. In this video, we have learned about the template design pattern.